Okay, here is the Excel shell file and all the inputs that we discussed are set up here. So we have the cost data and then duration data for each of the phases. So let's format this. Okay, so here is okay, so these are the input values. So let me give it like that. So these are the min, most likely, and max parameters for each phase. And so I already loaded at risk. So we have risk part, okay, minimum, most likely, and maximum. So that's the simulated input for the cost in millions. Okay, so let's see. Okay, so now we have a similar set of parameters for duration. Okay, so again, this is given input. Okay, now I can copy these four formulas here because they both use the same risk part. Now I need to remove the format from $sign because this is not dollar, this is duration in years. So I'll make it number. Okay, now that's done. And then here is the profit after registration. So again, that is a part distribution. So we can copy that there, and that is profit. So it will be in dollars. Okay, so let's do some more formatting, and these three are input values. Okay, and then we have the discount rate is given, and let's make it a percentage. And then we have probability of success at each stage, and those are given. So these are our prior probabilities. Okay, so now we have all of this input set up. Okay, now these are phase 1 through registration, and then we have profit and total discounted cash flow. So we're going to model this. All right. Okay. So progress here, whether we're going to succeed in the phase or not. So that's going to be our risk Bernoulli, okay, with that probability as probability of success. Okay, so now we copy that using each of these probabilities, and now if you go and click the die here, that's going to give you the generated value, either 0 or 1 for the first trial. Okay. Now phase 1, you have to start. There is no question of not having any cost or duration. So cash flow is going to be the first phase, the cost of the first phase. Okay. Now start time, you start at time 0. All right. So the discounted cash flow for phase 1 is the amount that you spend in phase one. So that would be the discounted cash flow for phase one. Now, phase two, okay. Now, the cash flow for phase two, 11.73, is only if phase one is successful. If phase one is not successful, then it will be zero. So we have to use a if function. If the progress is equal to 1, then we have a cash flow, and that will be cost. So you have to have minus C5 and then 0. Okay. And of course, the start time for phase 2 is when the previous phase ended, right? Previous phase ended when previous phase started plus the duration of the previous phase. So that would be the duration, the start time for phase 2. And that is the time. Okay, so that's the time over which the cash flow should be discounted. So that would be the future cash divided by 1 plus the discount rate. Okay, we have to do an F4 for that, and then to the power of the duration or the start time of the phase. So that would be the length of time by which the cash flow should be discounted. All right. So that would be currency to decimal places. Okay. Now these two formulas will be the same. Okay, for the rest of it. So we can copy these two formulas over. Okay, but this will be different because here we're going to have a cash flow only if the previous two stages are successful. Okay, since we are generating the probabilities independently and then making sure that the cash flows is the place where we are testing whether all the previous phases have been successful or not. So for phase 1, we'll always have the cost. Phase 2 is when phase 1 is successful, you have the cost, otherwise not. Now here, phase 3, okay, it is successful when phase 1 is successful and phase 2 is successful. So that would be the case with C26 times D26 is equal to 1. If both are 1, then only both stages have been crossed. So we can multiply those two and see whether that product is 1, in which case we have a cost, so that will be minus D5, otherwise 0. Okay. Now registration phase, you will start registration phase if, again, we have to do a product of all the 3 previous stages. So we can use the function product, okay, like that, right, equal to, product, we have to close parenthesis, equal to 1, then we have the cost of registration, otherwise 0. Now, you will have profit if all the previous stages are successful. So you have to do product of all 4 stages. Okay, close parenthesis equal to 1. Then that will be a positive amount because it is profit. So otherwise it will be 0. Okay. Now start time is, again, you just copy that. So it will be like the previous start time plus the duration of registration, so that will be the end time. That's the time duration over which we need to discount this profit. All right. So all of these values are discounted to the beginning of phase one. So the total discounted cash flow is nothing but simply sum of all that. Okay. Now we need to set this to be an output cell. Okay, so total DCF. Okay, so that's our model, and of course, after you run the simulations, you want to do a risk mean. Let's go ahead and set that up. Risk mean of that. Okay, that would be the expected net present value of the project. Okay, so we'll simulate in the next video.